interview with Paweł Trybała. He's from Bruno Kessler Foundation in Trento, Italy, but partly started his studies in Wrocław University of Science and Technology in Poland. So, Paweł, can you hear us?
Yes, can you hear me?
Yes, that's good. I will share my screen and your presentation. Okay, here you are.
Okay, so thank you very much for the introduction and good afternoon. I'm Paweł Trybała from 3D Optical Metrology Unit in Italy, but this is a PhD work that I carried out in Poland about application of mobile mapping systems, specifically in mining environment. So in traditional mining surveying, we have already some established methods of acquiring 3D data, like terrestrial scanning and photogrammetry. But of course, they're accurate, but also time-consuming, and the equipment is costly. So we are dreaming, let's say, of some more convenient methods and also to reduce the cost of operation. And the potential solution for that comes in mobile mapping systems, which utilize SLAM methods, or simultaneous localization mapping. And the core principle of these methods is that they acquire data during motion, but at a high frequency, so you can try to estimate the trajectory of the sensor moving through space. And of course, this research has been done for already quite a few years, so there exist in the market some commercial solutions, but the biggest drawback for us, for surveyors, is that they are closed source, so that we don't really understand how exactly the processing is performed, so we cannot really, let's say what the accuracy at different parts of the trajectory is to really satisfy the customer demands. And in research, on contrary, we have open source, clear algorithms for processing the data, but they have some other drawbacks, especially that they are driven mostly by computer vision robotic communities, so there is little focus on specific mapping. And in my research, I studied with a meta-analysis of articles. I analyzed over 10,000 articles to see what are the trends, open issues in all SLAM research, and specifically in application in underground conditions. They differ quite a bit from, let's say, generic urban scenarios. And here you can see some topic graphs and clusters divided in general SLAM and in underground SLAM research. So the conclusion from that is that underground conditions differ significantly, and you can see in a while some examples of images of the tunnels that I've been scanning. And of course, this is not a typical urban or indoor scenario. We have very unstructured environments. There is absolutely no global positioning. Sometimes they appear multi-floor, very unstructured environments, which pose a lot of challenges to normal mobile mapping systems. And in my thesis, I took an iterative approach. So first, I selected the best solution that I could find in the literature, applied it, tested it in field, and performed a exhaustive geodetic quality assessment of the results to find areas where I could improve, and then did it again all over. So this aspect of quality evaluation was very important here. So I used surveying methods as photogrammetry and terrestrial scanning to get the ground truth and to evaluate my methods in terms of the quality of point clouds, so accuracy, completeness, and precision of the results. And this is the final iteration of the system, which is called Polymap. So the cost of building the system is probably a bit over 2,000 euros. So it consists of a LiDAR unit with internal IMU, a processing unit for real-time processing, and other necessary accessories. And in terms of the software, I collected first some state-of-the-art components, so LiDAR inertial odometry, a loop closure detection module, and the puzzle of the trajectories, and incorporated some of my own improvements along the way, with the most important ones being inclusion of ground control points, ability to close the loop with a really high precision under centimeter level, and then add some extensive parameterization and in general robustification of the adjustment part of the SLAM. So you will see the last case scenario tested here. So this is the underground tunnel carved in rock, actually a staircase of over 100 meters here in Italy, and Polymap reconstructed it. And at this site, I collected also some ground truth with other SLAM systems, namely made by Leica and GeoSLAM. And you can see that from the results that the standard deviation of the differences between these point clouds was below 4 centimeters, and especially compared to GeoSLAM and photogrammetry, we greatly improved on the drift at the end of the sequence. So we are reaching really comparable results from many applications. And this is the fly-through of the point cloud reconstructed with Polymap and with the Leica solution. Of course, in my system, there is no camera, so there is no texturization of the point cloud at this point. But you can see that the general precision is very comparable and could be useful for many applications in the mining sector. And I'm happy to say that this work still lives. So it's being actively used in the European project .3D to scan kilometer level sequences in the underground tunnels of copper mines in Poland. And then here in Italy, I'm also working on some improvements to the system. So I believe that we can get to a really the most robust SLAM system, overlapping system, through inclusion of other sensors. So I'm trying to add multi-camera system for a next iteration of my SLAM overlapping system. And to wrap it up very shortly, the system that I developed tries at a very low cost to match accuracy of commercial systems, but also to give surveyors more insight into the processing, how it works, what are the accuracies that they can reach at different parts of the trajectory, so that they can really certify the result, the quality of the results they deliver. Thank you very much, and if you are interested, feel free to contact me on any problem. Thank you.
Thank you, Paweł. Of course, interesting. Yeah, questions from the jury? No experts in this field. Okay, if no questions, thank you once again, Paweł. We will continue